Good evening, Sahanya.
Good evening, ma'am.
Okay, we will start with the class. So today we will try to complete this lesson. Any doubt is there from the last class?
No. No.
Okay. So we need to discuss the terms related with the spherical mirrors. So let us define one by one. Here, first one we have the center of curvature. So what is center of curvature? Actually, the center of curvature, one point we discussed in the last class. That is, suppose if you consider your concave mirror or any convex mirror also, no problem. So consider a concave mirror. Here, with respect to this mirror, if you draw one imaginary circle, whatever the center is there, with respect to this center, whatever the circle you are getting, that is called as center of curvature. So this is for your understanding. How you can define it, you can see the definition. It is the center of the hollow sphere of the glass of which the mirror is a part. So you can see it is a part of, it is the center of the hollow glass for which your concave mirror or a convex mirror is just a part of that. Correct?
Yeah.
So the next definition is radius of curvature. So before going to define the radius of curvature, first I'll tell you what you mean by the pole. So see what do you mean by the pole. Here, this is a convex mirror and this is my concave mirror. The center of mirror, whatever you have, the center of the mirror is called as what? Pole. The center of the mirror is called as what? Pole. You can see here the central point of the surface of the mirror is called as what? Pole. So we saw this definition. We saw this definition. So two definitions completed. Let us define the third definition now. So this is again a convex mirror. So this is the pole. And here, this is my center of curvature. So here is. So this is my center of curvature. The distance between the center of curvature and the pole is called as what? Radius of curvature. You can see it is the radius of the hollow sphere of the glass of which the mirror is a part. You can say it like this also, or the distance between the pole and the center of curvature. And the center of curvature is called as what? Radius of curvature. Is it clear what is radius of curvature?
Yeah.
So three definitions completed. Center of curvature, it is nothing but the center of the hollow spherical mirror, and the pole is the center of the that reflecting surface, or the convex or the concave mirror center, it is called as what? That is the pole. The distance between center of curvature and the pole is called as the radius of curvature.
Okay.
The next one. So the next point is what? The principal axis. So principal axis, it is the line passing through the center of curvature.
Principal's axis?
Principal axis. So
Oh, okay. Like, why is it named as principal?
the central line. So it is named as the principal. Principal meaning is what? That is the main, like that it is, no?
Yeah.
Named as the principal axis.
Okay.
So spelling is different. So spelling you can observe. What is the spelling and what is that spelling? So see, the principal axis, it is nothing but the line passing through the, so suppose this is your center of curvature and this is your pole. The line passing through these 2 points is called as what? Principal axis. So don't get confused here with the radius of curvature. The line through center of curvature and the pole is called as the principal axis.
Okay.
The distance between pole and the center of curvature is called as the radius of curvature.
Yeah, okay.
No confusion, no here?
No confusion.
The next point is aperture. So aperture is nothing but what? The reflecting surface. Means, for example, if you consider concave, so whatever this front face is available for the reflection phenomena, this part is called as what? Aperture. It is called as aperture. Okay, the next definition. So total we have 7 definitions here. You need to remember all the 7 definitions. Principal focus. So the next one is the principal focus. So what is principal focus here? Before explaining, I'll show you the picture, then you may understand this principal focus. Okay, in this 14 point formation of the image in a convex mirror. So in this 14 point, you can see here F letter is there. See, capital F it is written. So here you can see this capital F. Right? Can you see this point?
Yeah.
So this is called as the principal focus. So how to define this principal focus? Let us define now. So principal focus is nothing but it is a point on the principal axis. So focus is nothing but what? It is the point on the principal axis, because you know that already the principal axis is the central line. So the focus is on that one. So first point is the principal focus is the point on the principal axis. From here, the lines appears to either diverge from that point, or if you consider the concave lens, the line appears to diverge at that point. Means whatever the reflected rays are there, they appear to diverge or they appear to converge at that point. That point is called as what? Principal focus. So how to define it? The principal focus is the point on the principal axis from where the line or the reflected rays appears to converge or appears to diverge. That is called as what? Principal focus. So if you want, once again, here we will see the definition, textbook definition.
Yeah.
It is the point where all the rays which are parallel and close to the principal converge or appear to converge. So if you consider the convex concave lens,
Yeah.
to take the convex mirror, if you take the convex mirror, just to diverge.
Okay.
So the last point, focal length. So what do you mean by the focal length here? Focal length. Focal length. Here you can see. You're able to see, this one.
Yeah.
So focal length means what here? Again, so this is my mirror and here is the pole, and here is the focus. It is denoted by the capital F. The distance between this pole and the focus is called as the focal length. Very simple. Distance between the pole and the focus.
Okay.
So based on the distance. One is from the pole to the center of curvature is called as the radius of curvature. Second is from the pole to the focus. Focal length. Yes, Hannah, 7 definitions are there. You can read all the 7 definitions. See, center of curvature is there, radius of curvature, pole, principal axis, aperture, principal focus, focal length. So go through all these points. If you have any doubt, you can ask. Otherwise, next point you can proceed.
I don't exactly have doubts.
Okay.
But here in the principal focus, it's a point where all the rays which are parallelly closed, right? So what do you mean by appear to converge over there?
Appear to converge means it is exactly not converging. It is just looking like it is converging at that point.
Oh, okay.
Okay, so that is called as what? Appear to converge.
Okay.
So for that reason they are using that word appear. Otherwise, simply they can say it as the converging point, but they are not specifying it as a converging or the diverging point. It just appear to converge at that point, means meeting at that point, or it appears to go from that point.
Okay.
That is called as the principal focus. Okay.
Okay.
So next point. I think next point in your book we have the uses. So let us go through that. So 7 terms are completed. The next one activity they have given, that is users need to
Slide
take.
only this much, like the chapter.
No, still lens is there. No, this is only mirror we are discussing. First we discussed
Oh.
the phenomena like reflection we discussed, image formation we discussed, lateral inversion. Then mirror we are discussing now. So in the mirror, two types are there: convex and the concave lens. Sorry, mirror. Then in the mirror, these 7 definitions we defined. Yes.
Okay.
So next, what they are explaining, one activity is there in your book, that is to study the image formation by the convex mirror. So you need to take a convex mirror and candle, matchbox, and one screen to see the image on that. Okay, so that activity no need to explain, no? Or you want it? No, if it is important for your exam point of view, we can say, otherwise we can go for the next point.
I think, yeah, they might teach us that.
Okay. So what you need to do in that activity is you just need to take one convex lens. So what is convex lens? So if you, sorry, not lens, that is mirror. So this is concave mirror, convex. So convex mirror you need to take. You need to keep one candle in front of this convex mirror. So after placing the mirror, that is the candle in front of the mirror, you need to observe what is the image formation. So what is the nature of the image formation that you need to study. Suppose if you don't have the mirror, what you can do is you can take that spoon, last class we discussed, no, spoon backward surface. So whatever the backside is there, you just hold it in front of that. You can keep a candle or you can just see your face also. So the image formation you need to study. So see procedure. You can go to your textbook page number 213, 213.
Okay.
Procedure they have given. See, take a convex mirror and place it on a stand. Light a candle and place it in front of the mirror. Try to collect the image of the flame on the screen. Actually, how it is, you just keep it in front of that. It is not that you will get the image. You need to set the position, okay? Set the position in the sense, little you may need to take it backward or you may need to take it front. So it is not that you are getting the image always. You just need to adjust the position of your object. Here your object is what? Your object is candle. So in front of the mirror, you need to adjust the position of the candle. Imagine here you are placing it and you are getting the clear image. So what you will observe that they're explaining. So be careful with the flame. Keep your hair and loose clothing away from the flame. They are giving caution also. Then observation. The image formed on the screen is here. Actually, whatever the flame is there, you are able to see its image. So therefore, the image formed, what is the nature of the image formed, that you need to note down. The image formed in the mirror. So these 2 points you need to note down. Actually, you have to perform this activity, then only you will understand this. Okay, in school, they may perform and show it.
Okay.
Yes. So can we go for the next point? That table they are explaining, see.
Yeah.
Formed by the plane mirror, convex mirror, and the concave mirror.
Yeah.
So see, that is the next point. Formed by the plane mirror, here box is there. So first we have the plane mirror, then we have the So in case of the plane mirror, here the image formed is always virtual. Hope so you remember what you mean by virtual. We have studied two types of images. One is a real image and one more is a virtual image.
Yeah.
The real image you can catch, or you can you can catch this image on the screen. Those are called as the real images. Which is not, that is called as the virtual image. So remember the difference between plane, concave and the convex mirrors. In case of the plane mirror, the image formed is always virtual. Second, in case of the concave mirror, the image formed is real and virtual. Actually, in your book, what they are saying, real except when the object is very close to the mirror. Here, actually, I don't know, in your book they have not given, but here I'll show you 1 second. Okay, so case 6 is there. See here, case 6.
Yeah.
So see here, in your textbook, what they're explaining for concave mirror, the image for the concave mirror is real, except when the object is very close to the mirror. Okay, so always the image is real for the concave mirrors, but only one case is there where it is virtual. So that case is here, case 6. See, when the object is placed between the pole and the focus. So now you know about the term pole and the focus already. So you can see in this figure, red color, one arrow mark you are able to see here.
Yeah.
Here, okay, actually two are there. Here I am telling. So this is any one object you are placing in between the pole and the focus. So as it is between the pole and the focus, what you can see, the object is very close to mirror, correct?
Yeah.
So in this case, whatever the image is formed by the concave mirror is there, that is what virtual. The image is virtual. You can see it is formed behind the mirror. You can see this arrow mark. So this is the image. Okay, so in your book, what they're explaining, hope so that point is clear to you. Yes, Sahanya, I'll repeat. That is, in case of the plane mirrors, the
Yeah.
image formed is always virtual. In case of the concave mirror is, it
Yeah.
is real, but
Yeah.
when it is close to the mirror, the image is virtual. So that time it is virtual. Other than that, it is a real image. So what about the convex mirror? In the convex mirror,
So,
it is always again
so
virtual.
is it as you told in concave mirrors? If you go
Ha.
near, it's virtual, but
Yes.
in convex
As you,
mirror, it stays virtual, or if you go near, it will stay real.
no. Irrespective of the position, it is always virtual.
Okay.
So you go near or you go far behind, if you go at the infinite distance, anything. So wherever you go, the image is always virtual in case of the convex mirrors. Okay.
Yeah.
The next point is, so second, what they're explaining is, what is that, obtained on the screen. So as you know that virtual images are not obtained on the screen. So therefore you can write here no. And in case of the concave mirrors, whenever it is real image, yes, you can catch the image on the screen. Or when it is a virtual image, you cannot catch the image on the screen.
Okay.
Same way with the convex mirror, it is no, as it is a virtual image. The third point, position of the image. So position of the image in case of the plane mirror, it is erect. So what is the meaning of erect here? Erect means the same size, means if you stand in front of the mirror, so you will see yourself. So 100% whatever it is, the same image you are getting. So that is called as what? Erect images. That is called as erect images. In case of the concave mirror, it is sometimes inverted. So when it is inverted, when it is real, that time it is inverted, and it is erect So when it is erect in the sense, it is when it is virtual, it is erect. So inverted and erect, these are the opposite words. Inverted means, suppose if you stand in front of the mirror, your image will be like this. So suppose this is your
Yeah.
head. So erect means you will get the same one, matlab, same head and toe position, head and leg position will be same. That is erect. Inverted means it is reverse.
Okay.
So for the convex mirror, again it is erect. Then the fourth point, what they're explaining is size of the image. So if you take a plane mirror, it is the same size. The same size,
Yeah.
whatever the size in front of the mirror, whatever the person is standing, same size image you are getting. So in case of the concave mirror, you will observe all the cases. You may see your smaller version also.
Yeah.
You may see the same size also. You may see the bigger size also.
Yeah.
So that is based on the position. Means if you are standing very close, it is different. If you are standing very far away, it is different. If you are standing at the center of curvature point of the mirror, it is different, like that. So in the concave mirror, you can see all the cases. Diminished means very small, same size, or it may be a bigger size also. Last, for the convex mirror, it is always diminished. It is always diminished. So diminished in the sense it is small in size, means actual size whatever it is there, other than that you are getting, means smaller version you are getting. So that is called as what? Diminished.
Okay.
Yes, in your textbook, page number 213, that 15.2 box. So they are saying the difference between the image formed by the plane, concave, convex. So you just go through that point. If you have any doubt, you ask. Otherwise, we will go for the next point. So see that point. That only I have explained you just now. So once you go read that one by yourself.
Mm. So like, are you like asking me to tell doubts?
I mean, if anything is there, you understood, no, this point clearly?
Yeah, I am.
Okay. So then we can go for the next point. So that whatever the table they have given, no, that is important.
Yeah.
Okay.
Okay.
Means plane mirrors, was concave mirror, convex mirror.
Yeah.
So nature of the image, size of the image, position of the image, and whether it is obtained on the screen or no. So that should be clearly with you. That point should be clear with you. Then the next point, we have the uses of the mirrors. So now plane mirrors, we know wherever we can use it. But what about the spherical mirrors? Where we can use the spherical mirrors? So examples like if you see the car headlights.
Yeah.
So in the headlights also they are using the mirror. The concave mirrors are used in the front lights of the car. Why? Because it will focus the light, means it will converge whatever the light rays are there, no, it will try to converge that. So therefore they are using the concave mirrors. You might have seen the lighthouse in the beaches. Yes, Sahanya, lighthouse you have seen. Yellow
I'm actually sorry, but like the computer's charge had gone and it locked.
It's okay. Actually, even I am having the same problem today. From morning here, there is no current. Another 10 minutes I'll take for you. Now I can take, no, it is there, no charging.
Yeah.
Okay. So see the next point, we were discussing about the uses. So in the uses, I told you that it is used in the car front, whatever the lights are there, we are using. You have seen the lighthouses
Yeah.
in the beach side. So in the lighthouse also they are using the concave mirrors. Solar, whatever the panels are there also the concave mirrors are used. So in short, wherever you just want to focus the light, means converging light you require, there we are using the concave mirrors.
Okay.
And the convex mirrors are used in the rear view mirrors in the vehicles, as these form the diminished and the erect image of the object. Means in the car or the vehicle, bikes and all, mirror are there, no? Those are the convex mirrors. Headlight is a concave mirror, but in the, what you can say, that is side mirrors are there, no, for the car or the bikes. Those are
Yeah.
the convex mirrors. So why the convex mirrors are required? Because behind the whatever the objects, like any vehicle is coming, anything is there, if you want to see that image, you require small image in your mirror, because that full entire object you have to see, no? So for that reason, diminished image where you will get by using the convex mirrors. So therefore the convex mirrors are used in the side mirrors, means side view mirrors. Those are the convex mirrors. Okay. The next, in the traffic signals also they are using. Then the concave mirrors, they are used by the dentist, barbers, as they require the magnified image. Means for example, if you visit a dentist, they will use a mirrors. So those mirrors are again a concave mirror. Why? Because to see that whatever the, what you can say, that is toothache, whatever it is. So to see that one, they require the enlarged image. So enlarged images, you can get it by using the concave mirrors. So you need to use the concave mirrors there. I think so here I have that. Means I'll show you. It's clear difference you can understand. So here convex mirror uses are there. See, vehicles frequently employ convex mirrors as the side mirrors. These side mirrors are mounted on the vehicle's flanks and allow the driver to observe the traffic behind him, ensuring the safe driving. Convex mirrors are preferred because they produce an erect, if diminished, picture every time. Furthermore, because they are curved outward, they have a larger field of view. As a result, convex mirrors allow the driver, means in short, what the drivers or the vehicle side mirrors are the convex mirrors. Similarly, we have the concave mirror uses.
Okay.
Concave mirror. Okay, here we have the concave mirror. It is used in the searchlight, torches, headlights of the vehicles, also used as a shaving mirrors, also used by the dentist to see the large image of the teeth, and the other uses in the solar furnace. So these are the other uses for the concave mirrors. So convex mirror, concave mirror, is it clear to you? Uses.
Yeah.
Okay. The next and the last part of this lesson, that is the lenses we have. So lenses means what? In case of the mirror, you are having only one curved surface. In case of the mirror, you have only one curved surface. So this is called as what? This is called as the mirror. Either it may be a convex mirror or a concave mirror. But if you see the lenses, means specs, whatever you are using, that is a lens. So here two curved surfaces will be there. This is called as the lens.
Yeah.
Okay, so here you can see the picture also for the lens. So here you can see there are two types of lenses again, the concave lens and the convex lens. So the lens, it is nothing but the curved polished piece of transparent material. So that is called as the lens here. If you see the convex and the concave lens, what is the difference in the picture? If you see the concave lens, so for the concave lens, it is thin at the center. The concave lenses are thin at the center, and at the edges it is broader.
Okay.
Thicker one, or you can, in short, you can say it as a thicker one at the edges, thinner at the center. If you see the convex mirror, reverse of that, at the center it is thicker, and at the edges it is thinner. At the edges it is thinner. This is called as the convex mirror. So concave mirror, convex mirror.
Okay.
Okay. So here the convex mirrors are called as convex lenses are called as converging lenses,
Okay.
and the concave lenses are called as the diverging. It is called as the diverging lenses.
Okay.
But if you see mirror, it is reverse. Okay, so in the reverse, what we have studied, mirrors, that is concave mirrors are converging,
Yeah.
and convex
the
mirrors are
convex
diverging. But here it is reverse. So clearly remember the difference between both. Okay.
Yeah.
So there how we have studied the 7 points like pole, center of curvature, principal axis, principal focus, then focal length, radius of curvature. Here also the same definitions are there. Very same, means exactly same. Only the difference is what? There our center point is called as pole. But here for the mirror, the center point is called as the optic center. It is called as the optic center.
Okay. Yeah.
Okay, so optic center is defined as the geometrical center of the curved lens is called as the optic center.
Okay.
The next point is the center of curvature. So center of curvature here with respect to convex lens, if I draw a circle, this is for one surface and this is my another curved surface. So here you can see one more circle. So center of curvature is nothing but it's the center part. So here I can take it as C1, this I can take it as C2. So what you can understand is in case of the mirrors, we have only one center of curvature. In case of the lenses, we have the two center of curvatures. Okay, so for example, if you see this is a convex lens. So here I will be having C1 and here I will be having C2. So convex lens, center of curvatures. Same way with the concave lens also. There also we have the two center of curvatures. Okay, so there how you define no for the mirror, same definition. Center of curvature, it is nothing but the point which makes the lens has two spherical surfaces. So therefore, in your textbook they have not given definition. So don't worry, no need to by heart the definition. Just remember there are two center of curvatures for the lenses.
Okay.
Okay. And the principal axis. So principal axis same. So the center line passing through the optic center like this. So this is called as the principal axis. Center, okay, exactly at the center. The line passing through the optical center. So suppose here this is your optic center O, and here it is little down. So suppose here. So this is your optic center. This is called as the principal axis. And the last point, that is the not last point, principal focus. So again, same, the principal focus is the point on the principal axis. Again, the light appears to diverge or the light appears to converge at that point. That is called as the principal focus. Here also we have the two principal focus. Center of curvature you have two. So principal focus also two are there, F1 and F2. Okay.
Okay. Yeah.
The last point is focal length. So focal length is, what is the focal length in case of the mirror? Yes.
Um,
This is only your
Sorry,
focal
I'm not
length.
getting that word again.
So how it is the distance between the
It's the distance between the
pole
pole
and the focus.
and the focus. Yeah.
That is
Yeah.
focal length. And here also same, it is the distance between not pole, here it is optic center. Okay.
Yeah.
It is optic center here. The distance between the optic center and the focus is called as the focal length. Yes.
Okay.
So here again we have the ray diagram and we have the what you can say, the image formation. There how you have studied for the plane mirror, convex mirror, concave mirror. Here also we need to study it for concave mirror and the convex mirror. That we will continue in the last next class. One more class we will take on this. Okay. Yes, Sahanya.
Oh yeah.
Okay. Even I have only 10% charging. So in the next class we will complete that last part. Friday.
Alright.
Okay. Okay. Thank you. Okay.
Okay.